Hi, everybody, and welcome to Room 9. My name is Mrs. Brewer, and I am a third grade teacher at Gordon Bush Elementary School in the East St. Louis School District. And boys and girls, once again, welcome to my math layer, my math cave. So what do you think, boys and girls? I'm going to teach you here in my math cave. I am definitely going to be teaching you a third grade math lesson. And of course, we're going to still be talking about multiplication because it is so awesome, okay? All right, so boys and girls, how are we feeling today? So those of you that are feeling great, give me a thumbs up. Those of you that are feeling just okay, give me a thumbs in the middle. And sometimes we have bad days, boys and girls, so give me that thumb down if we're not having a good day today. How are we feeling? And why are you feeling that way, boys and girls? Like I said before, sometimes just saying I'm having a bad day because starts turning that thumb down into a thumb kind of in the middle, and hopefully by the end of this lesson we'll have our thumb up and we'll be feeling better, or at least a little bit better, okay? So boys and girls, I am feeling great today, but I got thinking about all those days where I feel like this or I feel like that. And I just want to talk to you a little bit, boys and girls, about a power that I've learned about over the years. It's one of my secret math powers, too, that I have in my classroom. So I figured I might as well share it with my Room 9 classroom as well. And that is one word, one single word that can turn our thumbs down days and at least thumb to the side for thumb up days, boys and girls. And that is the power of yet. You guys ever heard of the power of yet, boys and girls? Well, I know that math doesn't come easy for everybody. And to be honest, boys and girls, when I was your age, math wasn't so easy for me. I loved science. I liked reading. Math was okay, but it never came easy for me. So I always had to keep working on my math skills. But rather than get down and upset if I couldn't do something right away, like multiplication, you may have some classmates that are rocking it. You may be one of the kids out there rocking multiplication, but there may be something else that you're not as great at. And we always use the power of yet in my classroom. Okay, I don't understand it. Multiplication is not coming as easy for me yet. Okay, boys and girls, and this is what we call a growth mindset. It means that just because I can't do something right now doesn't mean I'm never going to be able to do it. It just means I'm not going to be able to do it yet. But with practice and a positive attitude with that, okay, I might not get all of it, but I'm starting to get more each day as I practice. And that is the power, boys and girls, of yet. So if multiplication isn't coming so easy to you, it's not coming easy to you yet, okay? It didn't come easy to me when I was your age, boys and girls, okay? But I believed in yet, and now here I am. What am I doing? I'm teaching boys and girls just like I was all those years ago. Maybe not as many as you think, okay? And that's because of yet. I didn't give up. I didn't say I'll never be able to multiply. I couldn't multiply yet. And now here I am on Channel 9 in Room 9 teaching you boys and girls how to multiply. So even though I was your age, I just didn't get it yet, but it will come. It will come, I promise, boys and girls, okay? So today we're going to just take a step back to start with from multiplication, and we're not even going to skip count this morning or this afternoon or whenever you're watching me, okay? That's the beauty of being able to do this, boys and girls, all right? So we are going to start with, take a step back from multiplication and skip counting. We're going to go back to adding. So for some of you that say multiplication didn't come easy, but I sure understood how to add, now's your chance to shine, okay? So I'm going to write a multiplication problem up here. I just want to see if you guys can answer it for me, okay? So if I have 7 plus 6, okay, take about 10 seconds, boys and girls. Answer this for me. What's 7 plus 6? Someone, anyone out here, shout the answer. What's 7 plus 6? Ah, you got it. I heard someone out there say 13. Did somebody else get 13? Oh, I see someone over there got 13. Okay, you're exactly right. 7 plus 6 equals 13. Next question. How'd you get it? How'd you solve for 7 plus 6? Oh, I had someone tell me they counted up. So put up 7 fingers, count up 6, or sometimes I had students put up 6 fingers. We count up from 7, 8, 9, 10, 11, 12, 13. Is that a good way? Absolutely. It's one of our strategies we learned when we learned how to add, right? I heard someone say they just knew it. Well, that's that power of yet. You might not be able to look at this and know it, but guess what? You can't look at this and know it yet, okay? What else do we do? Somebody do something different? Oh, I like your idea you just said. You use mental math strategy, okay? And what did you do to use your mental math strategy? Oh, I just heard someone say they looked at the 7, okay? Boys and girls, everything I've taught you, I've tried to teach you easy tricks along the way to maybe make some of this not so bad for you, right? So when we think of mental math here, I always start with the 7 just because it's the first number we see, not because I like 7 better, okay? It's just the first number in my problem. So I see 7, and right away I keep thinking, what do I need to get to 10? Okay? What do I add to 7 to get to 10? Oh, I heard someone out there say 3. You're right. 7 plus 3 equals 10. Okay? So now I'm looking at my problem to see, do I have a 3 in my problem? Okay. Well, I do here with 13, but we're trying to solve this right now, right? So 7 plus 6, do I see a 3? Ah, I can use a number bond here, can't I? I know I can take that 6, boys and girls, and I know I have a 3 in that 6, right? If I pull out a 3, well then 3 plus what equals 6? Well, I'm going to count up from 3 and see how many times I have to count up to get 6. 4, starting with 3, 4, 5, 6. How many times do I have to count up? 3. So I know a 3 and another 3, when I put it together, becomes 6, right? So I've kind of just taken that 6 and broken it apart into a number bond, okay? So now when I think about this problem, I now think of 7 plus 3, right? Because I just broke up that 6, okay? 7 plus 3, but am I done? No, because I have to get 6. I still have to add what? This other 3 on. So I really had 7 plus 3 plus 3. It's really the problem I broke it down into, right? So what is 7 plus 3? We said that was going to be what? Our, fast 10, right? So now I have 7 plus 3 plus 3. What's 10 plus 3? 11, 12, 13. I just counted up, okay? Or I can add 3 ones plus 0 ones. It's 3 1s. 110 plus 0 10 is 110 to get 13, right? So even though I might not write all this stuff out, or if you have to write it out, you might not have to write it out in much longer, right? That's that power of yet, okay? So I use a number bond here to help me, just because I know what to add to 7 to make that fast 10. I know 7 plus 3. We should have our fast 10 down by now, boys and girls. If not, you don't have them down yet, okay? So I know to make that fast 10 here, boys and girls, I had to break it up into the 3 and 3, right? 7 plus 3, so I could get a 3 out of that 6, and then add on that other 3. Well, so boys and girls, I wonder, can we use a strategy sort of like this with multiplication? Let's try that today, okay? So keep thinking of these number bonds, all right? So hopefully some of you have seen this before, and if not, you just haven't seen it yet, okay? So I'm going to go ahead and erase my problem here, and we're going to look at a multiplication problem, boys and girls. So now if I had a number like 6, okay? So if I had 6 times 4, well, boys and girls, guess what? I can't skip count by 6 that well, even though I know how to dance to the mix, right? We're counting by 6, right? Okay. So even if I don't remember that skip count song that Miss Brewer taught me that was pretty rocking and awesome, right? I have another strategy I can think about using, okay? So let's think about these number bonds. And I'm going to use 6, okay? Once again, it just happens to be the first one here. But 6 has something kind of awesome about it. Because if I look at number 6, and I want to break it down into 2 numbers now that I can easily multiply by, okay? Well, one thing I know for sure are my 5s. Is there a 5 and 6? Well, yeah, there is, because we know 5 is smaller than 6, right? So I can break my 6 into a 5. And what's another friendly number then? What would I add to 5 to get to 6? I heard someone out there say it. 1. So my 6, I can break into 5 and 1. Do we know how to multiply by 5s? Yeah, we know how to count by 5s real easy, don't we? Do I know my 1s? Well, thanks to the identity property, I know any number I multiply by 1 equals what? Itself, right? So now I've taken a number I don't know, and I broke it into 2 facts that I do know, okay? So now I'm going to rewrite this problem, because now I don't just have one multiplication problem. I have 1, 2, right? So now I have 5 times 4, and I also have 1 times 4, okay? What's 5 times 4? Well, let's put up 4 fingers, and we'll count by 5s. Ready? 5, 10, 15, 20. That was pretty quick, right? So 5 times 4 is 20. What's 1 times 4? Well, we know any number times 1 equals what? Itself. Okay, so 1 times 4 would have to equal 4, or 1 4 times. 1 plus 1 plus 1 plus 1 is 4, or we're going to add 4 1 time, 4. Pretty easy, right? Okay, so now, what did I have to do to that 5 and 1 to get 6? Well, I know we have to add these 2 numbers together, right, to equal 6. Same thing here. To equal that 6, I need to add these numbers together, my answers together, my product together. So I'm going to add 20 plus 4. Okay. 0 ones plus 4 ones is 4 ones. 2 10s, there's nothing here, so I'm just going to bring it on down, right? And I'm going to bring my 2 10s here. What's my answer? Correct, if you said 24. 6 times 4 is 24. So I took a factor I didn't know, which was 6, right? I broke it into two factors that I know. And I know if I add 5 plus 1, it gives me 6, right? So I know if I multiply this 4 times 5 and the 4 times the 1, I'm going to have to add it together to make that 5 and 1 back together to equal 6. Okay? Let's try another one here, boys and girls. All right? So this will just, it might look kind of hard now, but you'll get it. You just don't know it yet. Okay? So let's look again here, boys and girls. Let's look again. All right? So now, what happens if I had 6 times 7? Okay? Let's try 6 times 8. Let's do 6 times 8. I think we did 6 times 7 the other day. Okay. Well, I can't remember how to skip count by 6. I remember how to skip count by 8. But hey, I know I have the 6 here, right? And I know what two numbers can I break my 6 into again? I know I can break that 6 into a 5 and a 1. Okay? So now, since I have 2 numbers here that I broke that 6 into, I'm going to need 2 equations here, multiplication equations, to help me solve this, right? Okay, I can't just do 1. If I did 1, it would have to be the 6, right? I broke it into 2 numbers, so I need to have 2 equations, right? What would my first equation be here? Let's just start with the first number we did. Does it matter which one of these we start with? No, I could start with the 5 or start with the 1. What do you want to start with? I heard someone say, let's just start with the 5 because we just wrote the 5 first. Okay, fine. So my equation will be what? 5 times, do we do anything to the 8? No. So my equation is going to be 5 times 8. Let's go ahead and write my second equation. What's my second equation going to be then? Oh, I heard someone yell it. 1 times 8. Now if I add 5 and 1, I have my 6, right? Okay. What's 5 times 8? Well, I can do that easy, can't we? 8 fingers. Count by 5. 5, 10, 15, 20, 25, 30, 35, 40. All right. So now I have 40 for my first equation product. What's my second product going to be? 1 times 8 is 8. So am I done? Count my marker, walk off, drop the marker, right? Marker drop. Oh, I'm not done. Why not? Way to catch me. I heard someone out there yell, you gotta add them together. You're exactly right. I gotta add them together. So what is 40 plus 8? 0 plus 8 is 8. And my 10s here, 4 10s, I can just bring it on down, right? So what is 6 times 8? You are correct. If you said 48, high five. You got this answer. Go ahead and dab it out for me 6 times. 1, 2, 3, 4, 5, 6. Woo! We got it. If you don't have it, you don't have it yet. Okay? So if you're still looking at this like, kind of get it, kind of don't. It's okay. The more we practice, the more we will get better at this, right? Let's look at another problem here, boys and girls, okay? So now this other problem we're going to give you is 7 times 3. Oh. You know, I'm not good at counting by my 7s or my 3s yet, but I'm going to see if I can use the strategy we just used, okay? Boys and girls, what we did is called the distributive property. Okay, distributive property. Okay, so all we did was we took a number, we broke it up, and we distributed some to one, some to another, and put it all back together. That's how I teach my boys and girls in my classroom. We distribute it, just like the teacher would come in and have a stack of papers. I gave some to this row, some to these students, right? And they do it, and then they do what? They put them all back together and give them to me, okay? Probably remember that more from last year than this year, okay? So let's see if we can use this distributive property. Everybody say distributive property. Okay, distributive property. So I'm going to look at the 7, okay? Just because, boys and girls, you know, I really liked working with that 5. And I know 7 is greater than 5. So do I have 5 and 7? Right, I have a 5 and 7, right? 7 is made up of 5 and what other number? I'm just going to put up 7 fingers if I don't remember. Put down 5. How many do I have left? I have 2 left. So I know my 7 is broken into my 5s and, oh, well, 2s to me are easy because I know 2s are my doubles. Okay, or I can just put how many fingers up and count by 2s, right? I can skip count by 2 as well, right? So either way I choose to do it, I have a strategy for 5 and 2. They're friendly numbers to me, boys and girls. There's numbers that I can work with easily, okay? So let me see if I can do this. So I'm going to have how many equations? Well, how many numbers did I break my 7 into? 1, 2. So I know I'm going to need 1 equation, 2 equations, right? First one's going to be with the 5. The second one's going to be with the 2, right? And what number am I multiplying? So here's my 7. What number am I multiplying 7 by? 3, right? So this would be what? 5 times 3 and 2 times 3. Oh, well now my 7s don't even seem so bad, do they? What's 5 times 3? Well, I'm just going to put up 3 fingers and count by 5s. 5, 10, 15, right? Or I could put up 5 fingers and count by 3, 3, 6, 9, 12, 15. Did it matter either way? No, because I got 15 both ways, right? Okay. 5 times 3 is 15. 2 times 3, well, I'll just put up 3 fingers, count by 2s. 2, 4, 6. Put up 2 fingers, count by 3, 3, 6. Both ways, I got what? I have 6. Am I done? Someone's yelling to me again, add them together. You're exactly right. I have to add these together. Okay. All right. 5 plus 6. If I take 5, count up 6, 6, 7, 8, 9, 10, 11. Okay. Oh, I can't write 11 here. I'm going to regroup 10 ones as 110, right? 110 plus 110 is 210. So what does 7 times 3 equal? It equals 21. Okay, boys and girls, I hope you have a pencil paper real quick right there. If you don't, take about 5 seconds while I'm erasing the board. See if you can find something to write with real quick. See if we can try one. We're going to stick with 7s. We did 2 6s. We'll do 2 7s, okay? All right, let's do 7 times, let's do 7 times 9, okay? Hopefully you got something to write with. If not, follow along with me. We're still going to use this distributive property, boys and girls, okay? What can I break my 7 into? Right, I can break it into 5 and 2, just like I just did, right? Okay, 5 plus 2 is 7. So how many equations do I need to write? 2. Okay. Boys and girls, while I write my equations, why don't you write yours and we'll see if we got the same thing, okay? Look at mine. Go look at mine, boys and girls. All right. Did you get 5 times 9 and 2 times 9? Awesome job if you did, okay? If you didn't get it yet. Look up here. Watch what we're doing, right? We broke our 7 into 5 and 2. I need to have 5 and 2 here. We're going to keep this 9. Okay. 5 times 9. Put up 9 fingers. Count by 5. Oh, someone shouted 45. Great job. I put up 9 fingers. Count it by 5. Got 45. 2 times 9. Or someone else say 18. 9 doubled. 9 plus 9 is 18. Okay, am I done? Same person keeps yelling, no, add them up. Okay. Let's add them up. 5 plus 8. 13. I have 10 ones. I'm going to regroup them as 110. 110 plus 4 10s. 5 10s. 5 10s plus 110 is 6 10. So 7 times 9 equals 63. All right. So what we did today, boys and girls, was called the distributive property. We took a number that we had a little bit of trouble with, and we were able to break it apart into 2 friendly numbers that we understand and we know, and we were able to multiply by. So here we could write 2 new equations using the 5 and the 2 as our new factors for 7. And then we had to put them all together at the end and add them up. Just like 5 plus 2 equals 7. 5 times 9 plus 2 times 9 is the same answer as we would get if we took 7 times 9. So the distributive property, boys and girls, is just another strategy we have for multiplying, okay? And I would suggest using the numbers that we did today. The 6, the 7, when they get hard, break them into 5 and 1 and 5 and 2, boys and girls, okay? But they will work for any other number as well. But we typically use it more with the 6 and 7s, okay? But whatever works for you, boys and girls. It has been another fabulous day with you, boys and girls, here in my math cave. I hope you guys have a wonderful evening, and I will see you back here tomorrow. Bye.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.